to the team.
All right, good afternoon. My name is Roger Lopez, production group leader here in Stamping Shop. Our team safety commitment is we'll always be aware of our surroundings during Getsu Genbutsu activity and always be aware of team members in the area. So today our QCC, our quality circle name is PI Predators, and our theme is actually Tacoma Hood Disasters. So this QCC was actually driven by team members on the floor. Our PI team member, which is the press inspection, are all really involved with our repairs in the shop. And there was a slight concern about excessive repairs in a certain period of time. So we kind of took a look at that and kind of targeted our QCC in that direction. So having said that, our team, myself, like I said, is the advisor. We had our sub-advisor, Dana Vada, who's our other group leader. QCC leader is Manuel Angel. Our theme leader is Becky Calderon, who could not be here today. She had to go on family emergency. So Manuel volunteered to take her slides to report out. So thank you, Manuel, for that. QCC members is Ronnie Uvedo, Maria Zambrano, David Espinosa, and Maria Felitello. So with that, I'll go ahead and turn it over to Manuel to go ahead and kick off our QCC presentation. Thank you.
Thank you, Roger. Good afternoon. Thank you for being here for our QCC. So like Roger said, this is team member driven, right? So what we noticed is our 2A and 3A repairs were really high in the shop. Here we have our 2A repair, 3,338 panels in repair. Our 3A repair was 2,827 panels. So we're going to attack our highest hitter, which is our 2A repair, 3,338 panels. So moving on to step one, clarifying the problem. Currently, ideal, we want 0 parts in repair on 2A press line. Currently, we have 3,338 parts, which leaves us a gap of 3,338 parts. So impact the shop, our productivity. We're unable to meet target lot sizes. Quality, flow out to our customers, causing extra work for our team members. Cost, high scrap count due to no good repairs. Moving on to step two, breaking down the problem. So as I mentioned, our 2A repair panel breakdown, 3,338 parts. We broke that down into individual runs. We noticed our highest hitter was actually die one, which is our Tacoma Hood outer, at 864 panels in repair. So we broke it down even further. Actual defects that were appearing on the panel. We have our bumps, dimples, distortions, scratches, and roll marks. Our high hitter was actually our dimples at 522 panels on Tacoma Hoods. We took it a step further and we went for our actual location on the panel where these defects were appearing. We had RA47 and LA47 at 253 and 175. So if you notice right here on our graph, these are our locations on the panel where we're getting these defects at on the Tacoma Hood. Moving on to our point of occurrence. So the first thing we did, we went to blanking process at MSTX blanking line, which is Millennium Steel, our on-site supplier. Next thing we did was we went to our blank receiving at TMMTX and washed at OW3. After that, we went to our blank actually being fed into onto our sheet feeder. Next, we had our blanks formed in our 1P draw die. After that, we went to our parts being fed into the 2P draw die. 2P trim. Next, we went to our 3P, 4P, and then last but not least, we went to our parts being loaded onto our pallets by our auto palletizer. So after using Getsu Genbutsu, we were able to find our port of occurrence was when our blanks are being formed in our 1P draw die. Now I'll hand it over to David for step 3.
Good afternoon. Step 3, set a target. We did. To safely eliminate 428 repeat defects on Tacoma Hood outer. By our location is RA47 and LA47 by April 30th, 2019. On die parts repair, from 428 parts, we're bringing it down to 0. 0 is our target. Overall impact to gap is from 3,338 down to 2,910 parts, and that's just under 13%. Again, for Manuel, step 4. 5.
Thank you, David. So moving on to step 4, determining our root cause. So of course we went with our 4 M's. The first one we have is our man. All team members are 100% certified in the process. Next, we went to our team members following standardized work, and that was good as well. Next, we move on to our material. So our material is within standard. Next, we move to our method. So we did find that we had contaminated blanks not identified. Why was that happening? Because the defects were missed in the inspection process. Why did that happen? Because the inspection standards / standardized work was not specific on what to look for. So now that we stopped there, we took it a step further, and we actually went to our machine, which is at MSTX, our blanking line at Millennium Steel. And we noticed that our blanks were contaminated with burrs and flaking. Why did that happen? Because the edge of the material was damaged. Why was that happening? Because the blanking tampers contacted with excessive force. Why did that happen? Because the pressures on the tampers was set too high. So when I say blanking tampers, what I'm talking about is this flat surface right here coming in contact with the radius of our hoods. If you notice on our diagram here, we have a small radius on the Tacoma hoods. So basically what this does is when those are getting blanked out, this tamper is coming in contact with excessive force causing our burrs and flaking on the blanks. Next, we're going to move to our developing countermeasures. So we came up with the countermeasure chart with the scoring system. So the first countermeasure we did was meet with MXTS, of course, to adjust the tamper pressure. That scored at a 13. Next, we had parts 100% sorted and confirmed with no defects. That scored at a 5. After that, we did a 100% sort with wire brushed edge of the blanks and to confirm we had no burrs. After that, we had repaired parts with defects and returned to body weld. That scored at a low of 5. Last one we have is our updated standardized work / standard inspection standards, and that scored at a 13. Moving on to our action plan. The first thing we did, like I said, we met with MSTX, Millennium Steel, to adjust the tamper pressure. That was done on April 16th, and that was the first time that we went over there for trial. Next, we had 2 pallets being blanked out at MSTX with the new settings that we did for the tampers. So like I said, that was the first time we went over there. That was done on April 17th. And we did receive these blanks still with burrs and flaking on them. Which leads us to our next one. We were able to come up with our flaking and no burrs wiped down at receiving prior to being washed at OW3. So we did receive those blanks. They came into our receiving process, and we used the wire brush to brush off those flakes and burrs to confirm they didn't have them on their blanks. Which leads us to our next one. We did 100% sort on those specific pallets, those 2 pallets, and we did receive great results with quality. That was done on April 18th. Last, we had our tampers pressure readjusted the second time we went to MSTX for a trial. And MSTX blanket line attachment was implemented. That was done on April 22nd. And the last one we had was add key points to our WISs. And we are working with Pilot currently, and that's still an open item to get our WISs up to standard for those blanking lines. So moving on to step 6, seeing countermeasures through. So like I did mention, we did sort 100% on our parts, and we did receive results in very, very good for quality. Like I mentioned before as well, flaking and burrs wiped down at receiving prior to being washed at OW3. So we did use these wire brushes to eliminate the flaking and burrs. Next, we have our tamper attachment was implemented at MSTX. Right? So when I say a tamper attachment, basically what this is, it's attachment that goes onto these tampers. It locks in onto that tamper. Like I mentioned before, it does have a radius on it, so instead of the flat surface hitting, it matches up with the radius of the hoods, causing no flakes and burrs coming to our shop. Next, I'll hand it over to Maria for step 7.
Good afternoon. My name is Maria Zambrano. So step 7, confirm results and process. So before we had contaminated blanks with burrs and flaking, causing countless defects to appear on our Tacoma hood. It also caused flow out to body weld, and that is extra work for our team members. Afterwards, working with MSTX, we were able to eliminate flaking and burrs, causing defects on our Tacoma. Before, as you can see, on our Tacoma hood, it was very highly impacted by defects, but after our countermeasures were implemented, our results were very, very good. Next.
Thank you, Maria. So now moving on to our step 8, standardizing successful process. So our internal Yokotan, we want to add key points to all our WISs on specifically what to look for when we're receiving these blanks. Right? Not only are we doing that, but we want to add maybe a chart saying what's good and what's no good to ship back to our Millennium Steel, or what we can receive in the shop. External Yokotan, we want to work with MSTX on standardize what is no good, or what is good and no good to ship to TMMTX. So we want to do that over there. So not only are we doing that, but we actually are preparing for a big project that's coming up with the next couple of years, which is aluminum. So this Tacoma hood is the closest thing that we have to aluminum, how soft that material is. So not only are we getting the jump start on that, we are getting Millennium Steel jump start on that as well. They're very excited to work with us to get ahead of the game for our aluminum that's coming up in the near future. So reflection chart, going off of before we started this 8-step process with our QCC, we were at a zone D. After that, we moved to a zone C for our team. My personal reflection off this QCC, this is my first lead on the QCC. I was able to help out my team members and team leaders understand the 8-step process. Not only that, but working with Millennium Steel was really big for us. Like Roger said, it was a difficult task going back and forth, but working with them, how excited they were to work with us as far as preparing for the aluminum that's coming up in the near future. Now I'll hand it over to Maria for her reflection.
Hi, my name is Maria Filoteo. I'm a PI. So my reflection is I learned about the AST process. So and after that, I saw in my area that defect went down in repair. So that means very good. So, and I'm very happy to work with my team. Thank you very much. Happy. David.
Hello, my name is David. Okay, because I'm a press inspector, we see a lot of parts that have to be repaired. With this 8-step process, to me, it means we'll be doing less repairing and more shipping out quality parts to our customers. Thank you. Yes, Maria?
So my personal reflection is, by having quality circles as the one we just presented to y'all, we will have less downtime on the presses, less defects on our panels. We will have less overtime on our team members. So the good thing is presses will have no downtime, the team members are good, and our plant will be very good.
Thank you, Maria. All right, so my overall reflection for this whole process was the collaboration between our production team members and our pilot press inspection team members. And again, like I mentioned before, with the MSTX, so that was a big challenge for us to be able to get on their side to understand their process and really determine what the root cause was. Team members really got involved with this QCC and really understood, like they mentioned, the 8-step process and determining root cause and really understanding the whole process and the importance of QCCs. I know in the past there's always been that, we got to do another QCC, but as these team members get involved, the next question is, hey, when are we going to get involved with our next QCC, or what are we going after next? So it was a very good experience to see these team members progress in this QCC. So I'm very happy to see that. So having said that, this concludes our QCC report out, and I'll go ahead and open up to any questions that they may have.